Greetings, everyone, and welcome to episode number 8 of the Pan Future Society podcast. I am your host, Sean. It is Sunday, July 10th, 2016. It's been a rough week out there in the world, and sometimes it really makes me wonder if we're going to get this whole civilization thing right and get it together as a species. And I think we will. Sometimes I think the media tends to focus on the bad news, which is not always a bad thing. We need to know what's wrong out there so we can do something to fix it. But sometimes you need some good news, and hopefully the show today decided to focus on our long story later on something that should be good news. But sometimes I do contemplate what if we don't make it for one reason or another, or perhaps we leave the planet altogether in our future generation ships to fly out into the galaxy. And we leave Earth behind for one reason or another, but it's still, let's say it's still habitable. Who would take over? I know there are some choices, good choices out there. Chimpanzees and orangutans and other great apes could be one. We've seen some movies about that, and maybe those movies will be considered documentaries in the future. Chimps and other great apes are obviously very intelligent, and they have the hands to do some work. Some other candidates I've heard kicked around out there, maybe elephants and dolphins are very intelligent as well. But I don't think, at least the dolphins, don't really have much of a way to manipulate their environment. I guess the elephants have the trunk, which is really a prehensile and agile thing to manipulate your environment with. That seems to be a prerequisite for, advancing technologically or something like that. Us humans have our hands to work with. I'm not sure what the dolphins would do. Birds might be a good choice. Especially members of the crow family are extremely intelligent, good problem solvers, have been shown to use tools at a very simple level. But again, I'm not sure how they would go about manipulating their environment to the extent that we have. My choice, personally, for the species to take over after we're gone is the octopus. If you've seen videos of these guys, they are extremely intelligent, for one. Plus, with all those suction cup covered arms, they can manipulate their environment quite extensively. There is one of my favorite videos out there is one somebody put an octopus in a jar, which might sound cruel, but it didn't stay there very long because it was able to unscrew the jar from the inside and get out. You hear stories about octopi getting out of their tanks at aquariums and crawling across dry surfaces to get to a different tank. And some of them have some really interesting hunting methods, including kind of fooling their prey by tapping it from one direction to make it run forward into the octopus's mouth. They are sea creatures, and as cephalopods, they don't have a bone structure. So I'm not sure that they'd ever have the evolutionary pressure to develop a way to get out of the water, but perhaps they could develop their own technology to take the water with them. Been some science fiction stories out there where the creatures are a water-based species, and their ships are full of water or something like that. So anyway, if you want to speculate about that, let me know what you think. My vote's for octopus for taking over. All right, now on to your news of the moment. Right, there is some research recently out of Harvard University The headline of this particular article reads, "Artificial human heart may just be possible thanks to this silicon stingray." Bioengineering professor Kevin Kit Parker has created a robotic stingray imbued with live heart cells that have been programmed to respond to light, allowing them to steer the stingray bot in different directions. What this might lead to is the ability to generate artificial structures that act as muscles. And this little robotic stingray, about the size of a penny, uses live heart cells from mice that have been trained in some way to respond to light, and using light pulses allows this little thing to swim through water. This little robot also uses a gold skeleton to store energy. So when stimulated by light, the cells around this gold skeleton structure flutter the little wings of the stingray so it moves forward. Now, this Parker is a bioengineering professor and has also engineered an artificial robotic jellyfish in 2012. And that one was only able just to keep itself floating. Now this little stingray can actually move. And one of the reasons he's worked with structures based on jellyfish and stingrays is because that these creatures, the way they operate, they are essentially a large muscular pump which moves fluid throughout their bodies as it also allows the animal to move through the water. So that's an interesting sort of method for moving fluids through your body. And the hope is that, among other things, this will eventually lead to a true synthetic heart. Of this work, Professor Parker says, quote, "Some engineers build things out of aluminum. I build things out of cells, and I need to practice. So I practice building pumps." So interesting work there. There are some others working on similar projects at the University of Illinois at Urbana-Champaign. Bioengineer Rashid Bashir, who's works on optogenetic biological robots, thinks that these can also be programmed for purposes such as environmental cleanup, like cleaning up toxins from water. So this is really early stage work, sort of proof of concept more than anything. But among many of the medical cutting edge things that I've been reading about, this combination of living cells with artificial structures and robots with actual living cells in them is a very interesting combination. And across the whole spectrum of these kinds of things, it's interesting to see where this is going. And perhaps in the future, it's not going to be living things and non-living machines, but quite a melding of the two. And that was your news of the moment. On this week's main feature story here, I'm going to talk about some bionics, bionic people, more or less. Not quite the $6 million man, I think. But in the last few years, there have been some really huge advances in prosthetics that people are able to use, and people who've suffered some sort of traumatic injury have been getting more and more of their lives back than they ever have before through the use of this modern technology and prosthetics. My grandfather lost his legs just above and below the knee when he was 8 years old. He had prosthetics and walked pretty well most all of his life. His prosthetics were made out of wood, plastic, and metal, uncomfortable and merely more functional than a pirate peg leg. He passed away in 2006, and I wonder what he would think of what we can do now and how much these things have improved in the 10 years even since he passed away. Technology is allowing us to race ahead in the design and practicality of prosthetics, leading to devices that are useful and also look cool to their owners. Beyond helping those who've lost a limb, there are people researching exoskeletons to assist the paralyzed, workers, and soldiers. There is also research being done in various types of brain machine interfaces related to a lot of things, including the control of prosthetics. This whole brain chip idea is a pretty interesting one that I'm going to save for a future show. Um, Prosthetics of various types have been around for a long time. The mythological Vishpala in the Indian Rig Veda, around 1200 BCE, is said to have lost a leg in battle as she was given a leg of iron. A wooden toe has been found in ancient Egypt, and there is evidence that Romans used dental crowns, although they may have been more decorative than functional. There are stories of prosthetic hands from ancient Greece, and in the Middle Ages in Europe, some knights would use metal hands to hold a shield or a lance. Moving into the 20th century, more advanced devices were made that allowed more flexibility in the use of the artificial limb. The use of flexible joints and springs, better sockets, and lighter materials like aluminum made the limbs more practical for everyday use. Later 20th century advances include joint replacement inside the body. Now materials like titanium and carbon fiber are making limbs lighter and stronger. There are also various methods that can be used to physically or electrically allow a hand to be opened or a knee to be moved. The latest breakthroughs in prosthetics involve what else? 3D printing. With the use of 3D printing, manufacturers are able to make limbs cheaper and just flat out more cool. One company I found, Open Bionics, seems to be leading this new charge. Obviously, cheaper is better, as most amputees in the world actually have no prosthesis. Some have hooks, and only a few have been able to afford something more advanced. And imagine you're a kid or a soldier recovering from a traumatic injury. Beyond helping you get your life back close to what it was, I imagine that it's also psychologically helpful to have a limb that you like. Open Bionics has created limbs for people based on the Disney movie Frozen, Marvel's Iron Man, Star Wars, and the video game Deus Ex. I'm a slightly avid gamer, and I do play Deus Ex. And the main crux of the video game is ideas of transhumanism, robotic cybernetic implants, and bionics. One of the prosthetics that Open Bionics just made uh, involves components to actually help the recipient play video games, which is really cool. And it looks like the bionic arm from the game. You can check out their website, it'll be in the show notes. It is a really great marriage of technology and art. And not only that, but Open Bionics also sells all the components that they use, which you could try out at home if you're interested in learning to build and program a robotic arm. Go on their website and buy yourself a 3D printed arm, much like the ones that they base their prosthetic designs on, and you can buy the computer components there and take a shot at programming. So that's pretty cool for them. This whole idea of price too, I wanted to get back to. A lot of amputees live in places that are war torn, that have problems with old landmines being left around, and in places like Africa or India, where there isn't a lot of money to buy any medical services at all. The less expensive these things are, the better. You know, we see stories about people like here in the United States getting these, and it's good. It's cool to see a kid with an Iron Man hand. getting to use his new prosthetic. But the fact is that most people who lose a limb actually don't get a prosthetic of any kind. So anything that can be done, I would imagine that the 3D printing is really going to carry that forward. Not only is it cheaper to make here and send somewhere else, I would think that the infrastructure needed to make that is maybe small enough that you could set up shop somewhere out in the middle of nowhere to make these things for people. Another area of research that I think we will see in use every day sooner than later is that of an exoskeleton. Exoskeleton is sort of a wearable machine that would give the user improved strength, speed, and endurance. And they could also be used in place of a wheelchair or other device to assist the disabled or the elderly. Early exoskeleton-like devices, there was one designed for walking, jumping, and running in 1890 by a Russian named Nicholas Yagin. It used compressed gas bags to store energy that would assist with movements. And although it was passive, it did require human power to make it work, but it would apparently make things easier for you to do. In 1917, U.S. inventor Leslie C. Kelly developed what he called a pedomotor, which used steam power and artificial ligaments acting in parallel with the user. The first true exoskeleton is considered, in the sense of being a mobile machine integrated with human movement, was created by General Electric in the 1960s. It was named Hardeman and made lifting 250 pounds feel like lifting 10 pounds. This used hydraulics and electricity and amplified the wearer's strength. Now, these earlier units are maybe interesting ideas, but mostly impractical for everyday use. They're large machines, they can be cumbersome, they're heavy, they need power sources which are not mobile. So really until recently, it was just sort of an idea that was waiting for the technology to catch up to it. Recent technological advances have allowed for these devices to become far more practical, and there are some in use today. MIT, Raytheon, Cyberdyne, and other companies have various devices in use, many for allowing a user to carry heavy loads, such as at work sites, and several to allow those without the use of their legs to walk. ESA, the European Space Agency, has also designed suits to allow people to control robots remotely. And these suits often work by sensing a user's movement and reinforcing that action. One of the biggest limitations right now to this technology is its power source. Batteries make these devices more mobile, but don't last long enough as they currently exist. Strength to weight ratio of materials and safety protocols are also a challenge to overcome, but the technology continues to advance rapidly. Much of the research into these suits is in military applications, which honestly I hope never gets used. But it is a fact of our era that the military often drives innovation. I would much rather see these put to use helping the elderly walk or allowing a firefighter to safely enter a dangerous blaze. Or imagine having a person in a small suit lifting debris at an earthquake site rather than having to get large, heavy equipment into place from some remote location. There's also work being done to design exoskeletons for rehabilitation for people who've had a stroke or a spinal cord injury. These exoskeletons are sometimes called step rehabilitation robots. And this would reduce the number of therapists needed by allowing a patient to be assisted by only one therapist, and the exoskeleton could be programmed specifically for each patient to customize their rehab program and to aid them along and keep track of how well they're doing. Also, of course, in Japan, a hybrid assistive limb robot is commercially available. This is something you could apparently just go and buy. So that's pretty cool. So beyond the development of these things, either for military or medical or rescue application, it is interesting to me to speculate if we will someday choose to wear these all the time. Will mountain climbers wear them? Will it be like the next level of extreme sport to climb Half Dome in 10 minutes wearing some sort of crazy exosuit device? Or much like the video game Deus Ex series, will we choose to replace our limbs for some specific purpose? Or will we augment our limbs with some sort of, will we be able to actually attach something to ourselves to have built-in scanners, or who knows what, I guess the sky could be the limit on that. As I mentioned earlier, the brain microchip interface will be a fairly large topic for another show, but that could be the next enormous step in this prosthetic idea, that a chip in the brain would allow full control of a prosthetic hand, just the same way you control your own biological hand right now. So, keep an eye out for the bionic people of the future. All right. Thank you so much once again, everyone, for joining me on this week's episode of the Pan Future Society podcast. Come visit us online at panfuture.org. Drop me an email at Sean, SEAN, at panfuture.org. Or find us on Twitter and Facebook. By the time this show goes up, there should be a donate button on the website if you would like to help out with the cost of the show. That would be wonderful. Anything you can chip in would be a great help to me. And I guess that's all I've got this week. Again, I hope everybody has a better week. I hope civilization has a better week. Be good to each other, all right? And I will talk to you again in the future.